Okay, Algebra 2, good morning. Hope you guys are doing well. So you should have completed part of the unit's study guide to prepare for the test today. That test is available in the classwork tab, but if you do have any questions or you want to see a live version of me solving any specific question, this is the video where you'll get that. So it's going to be pretty long, but what I'm going to do is I'm going to list out the time where each problem is being solved, so you can kind of jump to that if you only want to see a few problems. If you feel confident, you can just go ahead and start on your test in the classwork tab. Okay, so let's get started here. So I've circled all the problems that we're going to do. We're going to start off with number 1 here. So first we're simplifying rational expressions, and remember, all we do here is we just factor as much as we can and then simplify down as much as we can. So up in this numerator, it looks like I have a GCF of 6x. I pull that out and I'm left with 2x minus 5. Down below, I have 20x cubed minus 50x squared. That looks like I have a GCF of 10x squared. When I pull that out, I'm left with 2x and minus 5. And what you'll notice is we have 2x minus 5 in the numerator and denominator, so those cancel. And then we can simplify that down this little bit. 6 over 10 reduces to 3 over 5, right? 2 goes into both those guys. And x over x squared, one of the x's is going to cancel, so we'll just have an x in the denominator. So our answer would just be 3 over 5x. Okay, so moving on to number 2. With this guy, first I'm going to take out any GCF. It looks like 4 is a GCF up in the numerator, and down below it looks like 8 is a GCF. We have something like that. And then what I also notice is a squared minus 9 is the difference of squares. So I'm going to go ahead and factor it like a plus 3 times a minus 3. And then what you'll be tempted to do is cancel these guys out, which you can actually do, but because they actually are the opposite order, a minus 3 and then 3 minus a, this is one of those situations where it actually simplifies down to negative 1. So not just positive 1, but negative 1. So we got to add a negative out. And the other thing I'm going to do is the 4 over 8 is 1 over 2, right? So I'm going to have a negative out in front, which we had to add because of that, and then I'm going to have a plus 3 over 2. And we got our answer. And then this last one, we have to do some factoring of quadratics. We have n squared minus 13n plus 40. There's no GCF, but that's one of those guys where we can go n, and then what multiplies to 40 and combines to negative 13? Okay, that's going to be negative 8 and negative 5. And then down below, we don't have any GCF. This is one of our guys that you got to factor by grouping or one of your other methods. Okay, so I'm going to do this one quickly in my head, but we get 3n plus 1 and n minus 5. Okay, so once you factor it down, you just cancel anything you can. So n minus 5 is done, and that's as far as we can take it. So there's number 3. And then for number 5 here, now we're moving on to some operations with rational expressions. This is multiplication. So multiplication doesn't really change much compared to what we did in 1, 2, and 3. We just got more to factor. So I'm going to do a bunch of factoring here. This first one, it looks like I can factor out a 2, and I'm left with 25 minus w squared. Down below, I can factor out a 3, and I'm left with w squared plus 3w minus 10. This guy right here, there's no GCF, but it looks like a quadratic, so I'm going to factor it like w and w, and then go ahead and what multiplies to negative 14 combines to positive 5. I think that's positive 7 and negative 2. And then down below here, I'm going to pull out a 6 and get something like that. Okay, so I factored it a bunch, but there's actually still some more factoring I can do. If you notice right here, 25 minus w squared, that's the difference of 2 squares. So that's going to be 5 minus w times 5 plus w. And then down below here, we have quadratic. So I'm going to factor that to w and w. And then what multiplies to -10 and also combines to +3, that's going to be +5 and -2. And then this other side we can't take any further. And our final step is just cancel anything we can. So it looks like we have w minus 5 and 5 minus w. That's similar to what we had in number 2, where we have a very similar binomial, but the order is switched. So that guy's going to go ahead and simplify to -1. So we got to remember, we got to add a negative out in front. Right? W plus 5 and 5 plus w. Because it's addition, we don't have to worry that they are the opposite order. Right? They just cancel. And then w minus 2, w minus 2. And it looks like we have 2 over 6 will cancel to 1 over 3, right? Okay, so the things that are left, it looks like in the numerator, we're going to have a w plus 7. And then in the denominator, we're just going to have 3 and 3, that's 9. And remember, we have to put a negative out in front because of the way that one got canceled down. Okay, so let's move on to number 6. This guy's division. So the very first thing you have to do with division is you have to keep, change, flip. So I'm going to go ahead, I'm going to keep my first fraction. I'm going to change the division to multiplication. And then I'm going to go ahead and flip this guy. So it looks something like this right here. And now it's a problem just like number 5. So I'm going to go ahead and factor everything. So this guy looks like we can pull out an 8y from it, and we have 5y minus 4. And then down here I pull out a 5 and I get 5y minus 4. So let's see what we can cancel. Actually, you know what? We could actually factor this guy over here. I didn't notice, but that guy's going to factor down. Check out this tiny little eraser here. Pretty cool stuff. To 5 times y plus 1, right? I pulled out a GCF of 5. So this guy cancels, right? The 5s cancel. And then 8 over 2 is the same thing as 4 over 1. So that y is still there right there. So I have 4y times y plus 1, and looks like nothing in my numerator, right? So there's my answer. Right. So number 7 is another guy where we got to do a little keep, change, flip action. So we're going to start off by going ahead and factoring, or sorry, not factoring, doing the keep, change, flip, and then factoring. So this is going to become multiplication. I'm going to flip these guys. And now I'm good to go. So this top guy right here, I can pull a 2 out of. Down below, this guy is a quadratic I can factor. I'm going to do it in my head. You would have to do some keep, change, flip, or factor by grouping, sorry. And then up top, I got a difference of squares, so that's going to be 4c plus 3 and 4c minus 3. And then down below, 16c is our GCF, and we're left with c plus 3. Right. So the last thing I'm going to be able to do is this guy right here, just so I don't have to rewrite it, everything, I'm going to go ahead and factor this guy. So it's c squared plus 2c minus 3. So that's going to factor. I want to have a number that multiplies to -3 and combines to +2. So that's going to be, so it's -3 and +2, so +3 and -1. Okay, so now on to canceling. So c minus 1, 4c minus 3, c plus 3, 2 over 16 is 1 over 8. And I think that's all we got. So it's going to be 4c plus 3 over 8c would be our simplified version. Okay, so now we're going to move on to addition and subtraction. So the key here is having a common denominator. So sometimes we got to do certain things in order to make that common denominator happen. In this case, it's already there. So we can actually just subtract. Just make sure you kind of imagine parentheses around this guy. So it's going to be 6x minus x minus 20 over x squared minus 16. And so I just kept my denominator because it was a common denominator and we were subtracting. And then I got to make sure I kind of think of that negative of being distributed. So it's going to be 6x minus x, that's 5x, right? And then we'll have minus negative 20 is like adding 20. Right? And then we always want to see if we can simplify it down. So this one, I can factor a 5 out of the top and get something like that. And then in the bottom, you'll notice I have a difference of squares. So that's where we factor to x plus 4 times x minus 4. And we're able to cancel out the x plus 4s. Oh, sorry, that should be a minus there. And we get an answer that looks like that. That's a 5. Okay, sometimes we won't have a common denominator, and then we got to do a little more work. We got to kind of find one. So in this scenario, I'm going to start off. If you notice you can factor your denominator, go ahead and do it. And see how I was able to factor 3k plus 15. I pulled a 3 out as a GCF and got 3 times k plus 5. What that tells me is I could make this side have a denominator of 3 times k plus 5 by just multiplying the top and bottom by k plus 5. So up top I'm going to have 16k. I got to distribute this 16. So that's 16k plus 80 over 3 times k plus 5. And notice how we now have a GCF, right? They're both 3 times k plus 5. Right? So we can combine them into a single fraction, but we do have to be careful and make sure that we kind of think of parentheses around this guy and distribute the negative. So it's going to be 16k minus 4k, that's 12k, and 80 minus 56, and that'll give us something like 24. And then finally, to finish off, go ahead and factor. So I'm going to pull a 12 out from the top, and that leaves me with k plus 2. And I can take the 12 over 3 and reduce it to 4 over 1. So my final answer is going to be 4 times k plus 2 over k plus 5. Okay, let's flip it over. Here's numbers 10, 11, and 12. Okay, so with this one, I'm definitely going to start off by going ahead and factoring my denominator. Okay, hopefully you guys can see that. And it's going to be m, let's see, m minus 9 times m minus 1. And you'll notice that we can get a common denominator pretty easily by just multiplying this side by m minus 9 over m minus 9. So I'm going to take this 6, I'm going to give it to both those guys. So looks like this is what we're going to have. We're going to have m squared minus 7m minus 18. And then we're going to have plus 6m, that was 6 times n, and then minus, that's going to be 54. Okay. And that's it all over one fraction, m minus 9 times m minus 1. So what we want to do after that is we want to go ahead, we want to go ahead and combine any like terms and see if we can factor it further. So I'm going to show some work up here. M squared, don't have anything to combine it with. Negative 7m and 6m is negative m. Negative 18 and negative 54 is, that's going to be negative 72, right? All over m minus 9 times m minus 1. And then finally, let's factor that guy. That's going to be m minus 9 times m plus 8. And it looks like we're going to be able to go ahead and cancel out the m minus 9s. So our final answer is m plus 8 over m minus 1. Okay, for number 11, doesn't look like our denominators are matching up, so what we'd have to start off by doing is going ahead and factoring this guy. It's a difference of squares, so that's 2r plus 1 times 2r minus 1. And what you'll notice is this side over here, all it needs is a 2r minus 1 on the top and bottom, and we're good to go. So I'm going to go ahead and distribute this r in the numerator. That's going to be 2r squared minus r. And then we got this whole deal as our new denominator. And over here, we got 12r minus 6, over 2r plus 1, and 2r minus 1. So now we have the common denominator, and we can combine everything. So I'm going to have 2r squared. I got minus r, and then plus 12r, that's 11r, right? And minus 6. And then to finish off, we're going to have to go ahead and factor this guy down if possible. Okay, and 2r squared, that guy is going to factor. You're going to have to do factor by grouping for this, but I'm going to quickly do it just in my head here. So we got 2r minus 1 and r plus 6. And then check to see if you can cancel anything. 2r minus 1 and 2r minus 1 cancel. And we have our answer right there. Okay, and then finally for number 11, we have to get a common denominator, and we have a plus 4 over 8a plus 5 over 24. So it looks like if we just multiply this side of our equation by a over a, that'll give this denominator an a, but just like this one has. And if we multiply this side of our equation by 3 over 3, it'll make our denominator 24a, and then this guy will also be 24a. So I gotta give this 3 to both these guys. So that's gonna be 3a plus 12 over 24a, and this is gonna be 5a plus, over 24a when I multiply the a to both of them. So now I have that common denominator. When I do 3a and 5a, I get 8a. And then it looks like I can pull an 8 out, or sorry, a 4 out of that top, right? And I'm left with 2a. Sorry, that's a little messy. I'm left with 2a plus 3. And you'll notice 4 over 24, that's really just 1 over 6. So I get 2a plus 3 over 6a, and there's my answer. Okay, so now let's jump all the way to number 20. So this one's find the volume of the rectangular prism below. And remember, volume is just when we multiply length times width times height. So essentially all we're doing is just multiplying all these guys together. So I'm going to take that side times this guy times 3x over 5x plus 35. So remember, the first thing you do with multiplying, you're really just simplifying this guy down by factoring everything and canceling what you can. So x squared minus 9, that's x plus 3 times x minus 3. It's a difference of squares. Down here, I got x, and the two things that multiply to negative 18 and combine to positive 3 are positive 6 and negative 3. Right? And then this guy right here, I'm going to have x, and the two things that multiply to 42 and combine to positive 13. Let's think about that. Is that going to be 9 times 4? No. Let's think real quick. That'll be 7 and 6, right? Positive 7, positive 6. And then this last guy, looks like we just have a GCF on the bottom. Right, so did a bunch of factoring there, and then just cancel everything you can. So x minus 3, x plus 6, x plus 7. And it looks like we got 3x over 6x squared. So the 3 and the x would cancel. 3 over 6 is 1 over 2, right? And that would also get rid of one of the x's there, so I'm going to take away the squared. And it looks like all we have left is x over 3 over 2x. There's our answer. Okay, and then we have, we have solving some rational equations. So the first one I'm throwing at you is just a proportion where we only have a single fraction on either side. So this is one of those guys where you just cross multiply. So you should have got 3a equals a minus 8 times a plus 5. Right? And when you multiply this guy out, you're going to end up actually having a quadratic. So I'm going to FOIL this. A times a is a squared. Then I get plus 5a minus 8a minus 40. I'm also going to subtract this 3a here. So I got a squared plus 2a minus 8a minus 40. I'm going to combine these like terms. You get something like that right there. And then what we're going to have to do is we're going to actually have to factor this guy. Let's get a, and what multiplies to negative 40 and combines to negative 6, that's going to be negative 10 and positive 4, right? And then I use my zero product property to finish off. Add 10 on both sides, subtract 4 on both sides. So my two answers are negative 4 and positive 10. Now remember always to do a quick check with these guys and make sure that your denominator doesn't equal 0 when you plug it back in. And if we plug 10 in, not 0, negative 4, not 0, so we're good. Okay, and then number 23, for this guy right here, we had to get a common denominator before we could do any work here, or actually what we want to do is figure out that LCD, which would be our common denominator, but the smallest one possible. We have 2n, n squared, and 2n squared. So it looks like 2n squared is where we get all these guys to meet. So we multiply everything by 2n squared, and let's think about what happens here. Okay, so this is going to become 2n squared times 3 is 6n squared. So remember, we're only multiplying it to our numerators here. 1 times 2n squared is just 2n squared. And then this is going to be 2n squared times n minus 2 over 2n squared. And you'll notice all our denominators are going to cancel. 6n squared over 2n, that's just going to be 3n. 2n squared over n squared is just 2. And then the 2n squareds there are going to cancel, and we just have n minus 2 left over. And that's a pretty easy equation to solve. Subtract n, subtract 2, and divide by 2, and we get n equals negative 2. We got our answer. Okay, so I think our last couple are all our graphers. So that was 26 through 29. And what I'll do is I'll just show you one of each, just because this is becoming a very long video. So for the first guy, we just have some two reciprocal functions, which are a little bit easier. And remember, the shifts always work the same as they have in all our other types of functions we've dealt with. So the first thing I'm going to say is that x plus 4 means I'm moving left 4 units. My minus 7 means I'm going down 7 units. And those two shifts actually give us our vertical asymptote and our horizontal asymptote. So the left 4, right, just tells us that we have a vertical asymptote. That's a vertical dashed line at x equals negative 4. So got something like that. And then we also have a horizontal asymptote at our vertical shift. So that's going to be y equals negative 7, that down 7. So that's a horizontal dashed line like that. And these guys are also what restrict our domain and our range. So the only thing that x cannot equal is negative 4. The only thing that y cannot equal is negative 7. And if you were going to Desmos and graph this guy, you should get something that looks a little like this right here. Right? And then we have a little more complex situation when we have rational functions, which means we have a polynomial on top and bottom. Right? So in this scenario, what we're able to do to start off, let's figure out what our x-intercept is by just going ahead and setting our numerator equal to 0. So x plus 5 is equal to 0. I'm going to subtract 5 on either side. It looks like my x-intercept is going to be at negative 5 comma 0. That's right here. Okay. And then I can find my vertical asymptote by just setting my denominator equal to 0. So this is my vertical asymptote I'm finding. I'm writing VA next to it. I subtract 2, and it looks like I have a vertical asymptote at x equals negative 2. So that's a dashed line like that. And then our horizontal asymptote, this is where we use that highest exponent rule. And we basically just look at our numerator and our denominator and compare the exponents. In this case, the degree of both these guys are the same. They both just have a power of 1, right? We don't write it, but they both have a power of 1. So we can simplify this guy down. Right? Because they have the same degree, we just compare their leading coefficients. Both of them are 1, so that's 1 over 1, which tells us we actually have a horizontal asymptote at that point. Remember, we have a little chart in our notes that you should have had. Right? So remember, holes are if there's anything that cancels, and we didn't have anything that canceled, so we're going to put none. And then our domain is restricted by our vertical asymptote, so x cannot equal -2. Our range is restricted by our horizontal asymptote, so y cannot equal 1. And let's graph these guys, and we're going to have a graph that looks something like this right here. Okay, so I'm going to leave it at that. So I will once again create a little list for you so you can see which each problem is at and just jump to it. Hope you guys have a great day and good luck with the test.